What's up, guys? My name is Abram, and welcome to another great life sciences show on Learn Extra, where you learn more and learn extra with us. I've got Cheryl in the house, of course. It's the CA team in the building. How are you, Cheryl?
I was supposed to say yo,
what's
when you
up?
say in the house. Not quite sure what the lingo is. Evening, Abram, how are you?
I'm good.
Good,
What are we up to today?
We're looking at the eye. Yeah, the
Okay.
eye. Yeah, wink, wink.
All right, we're winking today. Well, guys, join us for this human eye session by simply getting your notes from facebook.com/learnextra. I've already posted the links for you guys. Also, go to our website, learn.mindset.co.za, but also follow us on Twitter @learnextra. We're here to help you guys. Remember, you can get yourself our workbook, which has the notes and the solutions, by simply sending an email to sales.mindset.co.za, and it's only for 139 Rand. So, guys, tell your parents to buy it for you, because I know you are watching with your parents. Cheryl?
Are we starting?
Let's do this.
Welcome, grade 12s. Tonight we're going to be looking at the human eye. If you tuned in last week, you would have seen we were looking at a section called the central nervous system, all right, or nervous coordination, where we're looking at, as I say, coordination. Just quickly, if I can remind you, is that a body making a right response at the very right time. You know, things change, and when things change, can you make a response exactly as it should be? So that's exactly what we call coordination. Tonight we're going to be looking at the structure of the eye. Now, when you look at the eye, you need to remember the terms from last week, and there are going to be a few terms like receptor, stimuli, nerve impulse, all of those, brain, which part of the brain do all of these go to? So a few of the things, if you can recap on last week. So when we're looking at tonight, when we look at the eye, all right, there's a whole lot of things that we're looking at receptors. What do I mean by that? When we look at the eye, we are going to have something that creates a stimuli, a nerve impulse. And when we look at the eye, you're going to see, I'm going to put in a block over there. Whenever you look at the structure of the eye, you need to remember the eye needs light. So how is the eye adapted to get light in so that we can put that image on a specific spot and we can take that to the brain to be interpreted? Okay, all right, so now we're going to I'm going to go straight on to, all right, the structure of the eye. You are going to pay particular attention to the eye, and then next week you are going to do the ear. We don't delve too much into a temperature, all right, pressure, pain, all of that. We're going to look at that when we do the skin a little bit later, but not now as we deal with the eye, all right, as a sense organ itself. Now, as I said to you, you always need to have, all right, a diagram. Now, if you have a look at the eye, remember what I said. Draw it or trace it if you can't draw that well. And first thing you need to know, and we're going to look at the questions tonight. We're going to put questions in the middle of the lesson each time, just to get you used to it. And you will see every single question is related to a picture. So if you don't have a picture of what the eye looks like in your head, you might struggle a bit. So now, as I said to you, let's go on to the picture of the eye. When we look at the eye, it is easier if you look at it as a bit of an onion. And if we onion, those of you who like Shrek as well, you know onion is made up of layers. And when we look at the eye, we actually see that there are three distinctive layers. You're going to find, I do yellow, because that gentleman last week kept on telling me he doesn't like the pink. Right, so on the outside, you've got to have layer one.
Try to use
what
red
you want?
or
My
your
red.
pink.
Must I try my pink? Is
Yeah,
it
'cause
better?
that's not
Okay, you must decide. I like my pink. I'm sticking to my pink now. Right, on the outside, we have a structure called the sclera. And then we're going to look at the layer underneath it, number 2, called the choroid. And then we're going to look at the very, very inside, the retina. So when we look at the 3 different layers, we're going to notice that the eye is obviously roundish in shape. Now, when we look at the structure of the eye, let's start at the front here. What do I want to be able to do? Number 1, my eye is, listen to this, a photoreceptor. What does that mean? A photoreceptor? Photo means light. A receptor means it's going to change the stimulus, which is light. I can shout into your eye. I can try and tickle your eye, all right, or I can touch your eye. It will not, all right, cause any kind of reaction. But if I shine light, which light is my stimulus, then I'm going to get a reaction. So a photoreceptor. Light is going to cause this little nerve impulse over here to actually function and to send a message. Now, as I said to you, what are we looking at? Number one, all right, when we look at the light, what must the light do? I'm going to say pass through. So number one, my light needs to pass through. Number two, a biggish word, but it's better when you use it, is the word refraction. And if you battle with it, remember it means to bend. Some of you who have a science background tend to find it a bit easier to understand the term because I know you do the light in class. So let's have a look at the structure of the eye. Number one on the outside, my sclera. What do I want it to do? Firstly, it's a very important organ. So any organ that's important, what do I want? I want it to be protected. So this outer layer over here is very tough. All right, it protects the eye. And what we'll notice when we look at certain problems with the eye, what do we also want the eye to be able to do? We want the eye to be able to keep its shape. So when we come to the sclera, and I'll try and use different colors for each of them, not the yellow. If we look at the outside, what do we notice? Tough outer layer, protect, and to keep the shape. Now let's follow this tough outer layer. And when we get to the front, we notice there's a whole lot of structures that are different in the front. And what does that mean? That means that the structures in the front, and I'm going to let me use the blue. Everything in the front must do the two things. Number one, let light pass through. And number two, we need to bend the light. Okay, so now we get the eye goes, let me go back to pink here, and my eye's got the shape. All right, why do we have a bit of a change in shape? If you notice this large area, what do we want to do? Look at all this blue. All right, if we go back to the blue, look at all this blue, all this light. Now, if we look inside the eye, right, we've got all these different layers. This little spot over here, let me make it pink again. That is a hole. Now, do you see all of this layer, all of this has to get through that little hole. So that's what we mean by bending. Okay, so when we look at the eye on the outside, all right, of the outside of the eye, what do I need to do? Light must pass through, but I've got a small little spot. How do I get things in? It's like me. If I need to put something in, what do I do? And it doesn't fit. I must be honest with you, I'm very bad. I tend to squash it all in, and I'm a crammer, right? You'll see, I'm not once a neat freak at home, but if I need to fit something in, what am I going to do to it? I'm going to squash it, and I'm going to force it in. Okay, and that's exactly what's going to happen over here. What you need to do is we don't squash light, we can't say that. We're going to bend it, and we're going to force it through the hole. This part over here is called the cornea. And that is where light is going to be refracted the most. And as you can see, it's part of my sclera layer. So it's part of the outside layer. So when you look at the eye, it's almost the white part of the eye. Now we get to layer number 2. All right, let's see, we're going to use purple over there, layer number 2. Okay, let's start over here. We will go there, and then we'll come back again. Layer number 2 is called the choroid. And if you look at the layer very, very carefully, it's very red. all right? And why would we have something that's very red? It's probably filled with blood. And if it's filled with blood, what do you think its function is? Our eyes is living, all right? We need to nourish it. We need to give it oxygen. We need to give it food. So that is the second layer. It's like when we make a sandwich, that's going to be your bread. Now let's follow. Let's follow. And if we follow, we're going to find some very interesting structures that form part of the retina. Okay? Let's look at each structure. We're going to have, can you see the pink all right? I don't think so. All right. We are going to have something called the ciliary body, which is muscle and ligaments. Right, now remember, muscles move. So we're going to have some kind of movement happening. Here in front, over here, whenever we think of eyes, I think this is what we think of. And that is going to be your iris. Right, and what is my iris? It's the color of my eye. Right, so it's the most distinguishable part. But the iris is also made up of muscles. And what do muscles do? Muscles need to move, right? Muscles need to move. So here, in this choroid layer, we have got these special structures, okay, that are going to cause some kind of movement. Okay, some kind of movement. Now, remember I said to you, if I squash something in and I jam it, right, I'm doing some kind of movement. So when I get to these structures of the eye in the front, they are going to be able to move. They must move, all right? They can contract and they can relax. And in doing so, they're going to cause some kind of movement that is essential, all right, for either allowing a certain amount of light into my eye. We're going to look just now at pupillary mechanism. Or when somebody comes closer to me, or when somebody goes far away, my eye needs to adjust. Okay, so there's certain movements that have to occur. So now if we go back to our structures. If I go back to the structure, let me see if I use red. Maybe that would be better. This little structure over here is attached to the ligaments. And that is my lens. And if I look at my lens is elastic. What does that mean? Elastic means that I can stretch it, and it will go back again when I don't stretch it. So I can stretch it, and it can go back to its normal shape. I can stretch it and go back to its normal shape. Okay, so that's what we've got so far. Now if I look at the inside of my eye, there's a very, very special layer, and we're going to have a look at the details later. The very inside of my eye is this layer called my retina. And my retina has got nerve cells, right? And nerve cells, they make an impulse. And if they make an impulse, they are going to carry the messages. Where do we want to carry it? All right, there's my head. Imagine that's my eye smiling. Here, I want to take it to my brain. I know your brain is not on top of your head, but that's where I'm going to take it to. Now, I've left out two things. And the two things I have left out is an eyeball must keep its shape. Okay? Now, we've done the outer layer, keeping a shape. But we need to make sure that there's something filling the eye that causes it to inflate. Imagine if we want a balloon to inflate, what do? We blow into it and it inflates. Right? So if we want it to stay shape, we need to fill it with things. So what do we fill it with? We've got two chambers. Here in the front, over here, you will see, we have got a chamber that's filled with water. It's called the aqueous humor. And here at the back, we have a chamber that is filled with a more jelly-like substance. That is called the vitreous humor. And in doing so, they give the eyeball the shape, and because they're quite dense, they ensure that the light rays, right, when you get into you want the light to go in. And when we look at the spot, have here, let me do it in, I'm going to choose another color. Let's do it in purple. When we get to the spot over here, my fovea centralis, or my yellow spot, I want, it's tiny, tiny, tiny. That light must fall directly onto that spot. So everything inside my eye must make sure, how do I get light in, and how do I bend it to get onto that spot? When we come back, we'll do a question.
Okay, that's if you still see me.
Can I see you?
I don't know.
No, my eyes, I'm getting old, but my eyes are, I can
You need to
see.
put on
Any
your
further, I'm
glasses.
going to be doing that. I have glasses.
Oh, okay. You need
yeah.
to start putting them on.
I don't need them for that.
I'm
If you tell
kidding.
me I'm old, I'm going to smack you.
I take that back. Well, guys, thank you for your comments and your questions. We'll see them right after this break. Now, as a matriculant, winning is very easy. You could get yourself 1 year of free accommodation courtesy of South Point. All you need to do is to fill in an entry form, and your name is on the box, and you could win yourself that 1 year's free accommodation for next year. So if you're a matriculant who's watching right now and are looking at studying next year at any tertiary institution or university, make sure that you enter competition right now. Well, Cheryl, I've got exciting comments and questions from the guys watching now.
Okay, a lot of your comments are coming through about accommodation and pupillary mechanism. I'm going to get to that now. I just wanted to start off with the structure of the eye. So this one, we're going to do pupillary mechanism, and then we're going to do accommodation. So if he's not answering, you hang tight. We're going to get to it. And if after that you don't understand, we're going to be here for you. Right, just quickly finishing off, you see my little diagram over here that looks all terribly dear macabre and everything. It all looks like a mess. If you go to the notes, I've posted this picture there as well. You know, by now you should know me. I am an annotated diagram queen, right? I'm a visual person. So I always, and I make my kids do that as well, is when I hand out this big piece of paper, they're like, oh no, you've got to be kidding, right? But here's a picture of the diagram, and look what I've done. For each single one of the labels, give the function, right? Give the function. Let's look. So if I go to this question over here, okay, it says study the diagram that shows the anterior, now let's change color, the anterior, that means front, and the longitudinal section, that means a side. So when it comes to the diagram of the eye, you need to look very carefully. They can give you a diagram that's from the front, this would be the anterior, all right? Or they can give you the one that you are more used to, that will be longitudinal. Remember, longitudinal, I take it and I've sliced it in half. So you need to know, first question is a nice general knowledge question, okay? Identify parts numbered 1 and 3. So if I know what my labels are, I'm then going to be able to. Question number 1, answer number 1 looks a bit confusing because you think, what on earth are they showing? But if you have a look at number 1, they've showed you, by showing you the front, that they want you to do that label. And that label is literally a black hole. And number 1 is then going to be my pupil. So I write, number 1, pupil. I don't just label randomly. I set it out, each number telling me what I need to do. Number 2, and then number 3. If I go to number 2, what is number 2 showing me? Number 2 is showing me from the front of the eye, what are these things that go around here? And we're going to look at them now. They are the muscles of the iris. So they haven't asked you for the muscles, they've asked you for the part. And the part would then be the iris. Now, number 3, we go to number 3. And number 3, we're looking here at something that is joined to the lens. Now, you don't get too confused when it comes to that diagram. Very often, let me draw it over here. You've got 3 parts you need to understand. One is the lens. If it's pointing to structures that are touching the lens, there we want to know your suspensory ligaments. Okay? And underneath that, because muscle does not attach to my lens. If my muscle was to attach to my lens, I would have torn my lens and I would have damaged it far, far earlier. So they're pointing to the structures that are attached to the lens. So number 3, what am I looking at? I'm looking at my suspensory ligaments. And I've set it out all nicely. I've said number 1, number 2, number 3. Now, question number 2, I want to know the function. And if I look at where my suspensory ligaments are attached, they're attached to the lens. And what they are going to do is their movement changes the shape of my lens. My lens plays a very important role when it comes to the eye. The lens, if it's thin or if it's fat, it's going to make a difference at how my light bends. So what is the function of number 3? It is to, you can say, control, or to make, or to enable the lens to change. Don't say move, because the lens doesn't move. Movement means get up and run. Okay, so the lens to change its shape. Right, and here we're showing you, we want a long, skinny one, or we might want a short, fat one. I'll take your guess which size lens I am. Okay, name the condition responsible for. Number A, the condition. We're getting to these ones, but as I say, they're relating. All the things relate to the structure of the eye. The size of structure 1. Now, if you don't know what number 1 is, you're a bit stuck for the question. Number 1 was the pupil. Now, what is going to change? All right, it's asked you, name the condition. And we call the condition, and that's what we're going to look at now, a pupillary mechanism. And what does that mean? Quite simply, I need to make my pupils different sizes because I need to control the amount of light. All right, and the next one, number B, the shape of the lens. My lens, as you look up over here, needs to change shape according to an object's distance from me. So when an object comes closer, right, seeing far is actually quite natural. When an object comes closer, the name says itself, accommodation. If you accommodate somebody, you make them feel comfortable, right? And that is exactly what we want to do. Okay, now some of the questions. Let's go on to the pathway of light through the eye. You need to have a general knowledge structure of just list. You can just do an arrow. Where does light go through? From one to the other. Okay, so what I'm going to do, we're going to start 1. And we know at each time, it's just going to pass through. It's either going to pass or it's going to bend. So, how does the light go through? Got a diagram over here. So we start off. We're going from structure to structure. It starts off, light needs to travel through the cornea, number 1. What is the cornea? All of these are transparent. The light can pass through. What also happens at the cornea, right, is refraction. Refraction means light bends. So number 1, my cornea. Where is number 2? Number 2 is my pupil. Okay, let's put here, I'll start here. It's easier to see. Number 2 is my pupil. It does not pass through the iris. So my iris is not a structure that is going to allow, okay, it's going to allow the light through, but the light doesn't go through the iris. Number 3 is where? Here is my lens. There is number 3. Light will pass to the lens. What happens at the lens? All right, what happens? The lens, it bends again. We have refraction. Where does it pass? All the way through, number 4, it passes through my vitreous humor, number 4. My vitreous humor. Where does it land? On your, all depends on your teacher, fovea centralis. I find yellow spot easier to remember. And here we go, for some of you who are asking. If we have a look at this, right, picture over here, this little area of my retina, if I were to enlarge it, that is what it's going to look like. And what you notice here are nerve cells. And nerve cells carry messages. Now what has to happen, remember what is my light? Photoreceptor. So when the light falls on these little nerve impulses, what do? Message. What do? It's like all you guys, you have a WhatsApp group. What do? You send one message and everybody passes the message on. So here we go. Pass the message on. Another nerve. What do? I pass the message on. Another nerve cell. I pass the message on. And that message is going to go via the optic nerve to the occipital part of your brain. Now, one of the viewers wanted to know what is a rod and what is a cone. Now, you do not need to know the structure of the two. Here's a rod and here is a cone. Okay, now when we look at it, I remember it like this. C stands for color. So imagine those of you who do have access to a printer. If you've got a color printer, you're going to have all the color cartridges. So there's going to be red, there's going to be green, there's going to be blue, there might be yellow. Okay, all of those. So they are going to, you perceive color when it falls on this nerve. Now when the sun goes down, now at nighttime, we don't see color so much. We need, see, even the diagram is in black and white. Okay? My rods need to tell the difference between black and my grays. So that gives me the much darker perspective. So if I'm looking at my eye over here, here's my, let me draw a diagram over here. Let me draw it over here. Okay. Imagine this is my retina, and this is my fovea centralis. My cones are going to be on my yellow spot, because that's where I need the sharpest vision. My rods are going to fall off of my yellow spot. And there I just see the black and the gray. So if my light comes in and it falls on different parts of the eye, right, what I'm going to see is, if it falls on different parts, I don't see really, really well. The reason being, this is the spot I want to make it. So, in soccer, is it a goal if you miss the goals? No, all right? How do you score a goal? It's very easy. I need to get the soccer ball into the net. How am I going to see properly? I need to get the light into the net. And my fovea is the light. That is the light, right? If I hit it, what happens? If the ball goes there, or if the ball goes there, I miss. It's not a goal. I don't see clearly. So what am I aiming for? I need to make sure that, as a goal, I need to make sure I hit the spot. And any kind of change in the shape of my eye, if something happens, if my cornea is different, if my eye is a little bit long, or the lens doesn't bend right, what's going to happen? I'm going to land, I'm not going to get a goal. So I'm not going to be able to see properly. So now, next thing, pupillary mechanism. You need to be able to change the amount of light that comes into your eye, right? And this is what we call a reflex action. If I go into bright sunlight and I bring lots and lots of light into my eye, what could I do? I could damage it, right? If somebody shines a really bright light into you, what's going to happen to my retina? That really bright light can damage my eye. The same as if I go into a place that's dark, I might need to be able to get more light in now Because it's really dark. So that is, what do? I change my pupil size. Now remember, the pupil isn't a structure. The pupil cannot do any work. I always say to my kids, if I had a pin, I could prick you through the pupil because it's a hole. But because it's a hole, around the hole, if we have a look over here, what are we going to find? Oopsie, sorry. We are going to find muscles. When we look at the eye, we've got two different types of muscles. So as you draw, circular, let's go back to pink. Circular means round. Isn't that a circle? I know it's a very conky circle. Now it's a muscle. What happens when that muscle contracts? When it squeezes. Now let's look. If I show you, this is round. This is a round thing. And when a muscle contracts, and it's all in a round ball, I squeeze. And if I squeeze, what do I do to my pupil? I'm squeezing it, right? What do? I make the pupil smaller. So that when I go into bright light, I don't want my eyes to be damaged. So what is my body? It's a reflex. What is a reflex action? It protects me. It makes sure that I don't damage myself. So when I go into bright light, what happens? Right? My pupil, okay, it needs to, let's dilate and to contract. Okay, dilate. Dilate means to grow bigger. Contract, reduce the amount, or constrict. You can actually use the word constrict, it's better. Now what happens at night? I get up, and as you get to my age, you go to the bathroom a lot at night. What do you need to do? You need to see in the dark. But it's dark. Dark means the absence of light. So now my eyes need to try and get in as much light as possible. Okay, so let's have a look at these muscles. These are called, all right, so we've got circular muscles and then we've got radial. What does radial mean? They go outwards. Don't you do when you do a circle, the radius, all right, is half of the diameter. So now what happens is, now I've got radial. Radial means outside. So where do my eyes do? What do the irises do? They pull. Remember, muscles work. And when they pull, what happens? My pupil dilates, right? It gets bigger, dilates. So the words I want over here, my pupil constricts. That means it gets smaller. Here, I've even got it for you. And when I'm in a dark area or dim light, what do I need? I need my pupil to dilate. I need to get more light in. Okay, so that is called pupillary mechanism. If we have a look quickly at this question that we started off, you will very often find a question has all of the elements in. So this question that we had to look at over here, right, it's the second part of question number 1. And it shows you, it gives you a scenario, we're not going to go into too much detail, that a person goes into a darkened room and asked to cover one eye. Right? A dim electric bulb positioned at varying distances, not all measurements is switched on at 1 minute intervals for a period of 10 seconds. During this period, the diameter of the pupil of the eye is measured. The results obtained are shown in the table below. Okay. Soon as you see darkened room, you need to look at pupillary mechanism. Because it's darkened, and what are they going to shine? They say to you, over here, they have electric bulb. So you are going to initially, you go into a dark room. What is going to happen to your pupils? They're going to dilate. And as soon as I shine a light on them, the body's protective instinct kicks in. And what's going to happen? It's going to constrict. And what they've asked you to do here, right, is to provide a title for this table. Right, have a look at what you're given. What would be the title for the table? I start off with the obvious, a table. Oopsie. Okay. Oh, now let me can't even spell table. Right. Just telling Abram how bad my family is at spelling. I don't think he realized that I was quite so serious. Okay, you wouldn't realize, eh? Okay, a table showing what? The diameter of my pupil, because that's what it says. I'm just going to take what they give me. Diameter of the pupil at different time intervals. And now they've asked me, which structure in the eye controls the size of the pupil? The iris. Remember, the pupil is not a structure. It cannot do the work. It's the iris around it. And I can ask you another way of doing the results. If you have a look over here, I take the table and I'm going to put it into a graph. Now, for some of you, right, which axis is always a problem? This is my x going that way, and I always draw. Okay, most of you are good at drawing. Remember, y goes down like that. What do I put on the x? I put on the x my independent variable, what I chose to do. And what did I choose to do? I decided on the time. Okay, so what's going to be on this here? Time in minutes. I decided when I was going to shine the light. My y-axis is my dependent. And what does that mean? That basically means my results. Did I have any control about the size, the diameter of the pupil? No. So I'm going to put diameter and units of measurement. Okay, and then what I'm going to do, just drawing it briefly, I'm going to draw in the dots, and then I'm going to draw a line graph. Are we finished?
I think we should
Yes.
take a break.
Okay, tell them when we come back, we're going to do accommodation. Promise.
Guys,
And
you've
then
been
we'll
wo-
answer questions.
Of course.
Okay.
You heard that? We're going to be doing accommodation after the break, guys, so do stay tuned. See you. Welcome back, guys. So, are you worried about accommodation, getting it right? Well, it's easy with us. Enter the South Point competition and you could win yourself 1 year of free accommodation, or you could enter also to win a car to drive to your accommodation. Enter the Be a Bright Spark competition because winning is very easy. Buy yourself the Safeways K53 manual or download the cool Android app, which is available for only 59 Rand, guys. All you need to do is just to get those things, the book or the app, and then fill in the entry form, and their name is on the box. And the exciting news are the winner will be announced soon. So watch more details. I'll be posting on Facebook, and I'll tell you before the end of this show. Cheryl,
You're so funny.
what did I do?
You're so funny. Accommodation.
Yes.
Accommodation. We're now going to do accommodation.
It's not funny.
That's funny,
anymore.
no. It was funny in the beginning, but then you teased me, so then it's not funny anymore.
Sorry.
Okay, guys, we promised you accommodation. Okay, now if you have a look at the diagram, okay, on the board, I want to explain something to you. Believe it or not, actually looking at a far distance is when it's actually normal vision. You need to be able to change or accommodate, okay, nudge, yeah. You need to accommodate, your eye needs to change to be able to shrink that image almost onto your retina. So now, as I said to you, remember what your eye needs to do. We've looked at how the light goes through and how we can control it. Now we need to look at, when we're looking at something, is the object far away or is it going to come closer? And we generally say, if an object comes 6 meters or closer to us, our eye needs to accommodate. Now, if you have a look at the diagrams over here, you will see what I mean by accommodation. And I've simply put it in these diagrams. The lens, all right, let me go. The lens has to change its shape. That is how it works. Accommodation means that when my lens, when I'm looking natural, this is natural, all right? When I'm natural, my lens is actually relaxed. When something comes closer, and always say, remember, have a look what happens. When it comes closer, when an image comes closer to me, what do I have to do? I need to fit it in, right? When it's far away, something looks like that, but as it comes closer, look, imagine my hands are the lens. My lens, I need to fit in. Look at me again when I said, what do I do when I need to stuff something in my cupboard? I cram it and I stuff it. And that's exactly what's going to happen here. So quickly, what I need to do, and for those of you who go to the notes, this is an awesome way. It's in order and it tells you exactly what you need, because very often this can be a nice 6-mark question. So I'm going to concentrate on when an object comes closer. How is it possible for my lens to become so, all right, convex? Now, what we're going to see is, that's why I put this little diagram over here, because a lens cannot move. A lens does not have muscle. So what do we need to have? My lens will move if, what happens? My suspensory ligaments, I'm going to put there ligaments, or my ciliary muscle. All right, something's going to happen here. Okay, and I want to explain to you what happens, because I'm going to use my fingers when we do this. I want you to understand when the eye is at rest, the muscles are actually, when you are at rest, is this at rest or is that at rest? Okay, this is at rest. So when my eye looks at the far distance, look at my muscles. They are relaxed. Now all of a sudden, Abram comes running to me to give me some water. Okay, you usually give me water, so that's why you're so kind. Right. So Abram comes close to me, he's running, he's going to come give me water. And I need to remember all about coordination. What do I need to make sure? I need to make sure that he runs to me, I'm able to look at the glass, I can see it, I can fit all the image in. So now I'm laid back. As soon as he comes in, I need to change my posture. Now look at where the muscles go. The muscles contract. You often think that when a muscle contracts, that is contracted. No. For your eye, this is relaxed. And as soon as my image comes closer, look what my muscles do. They contract. Now, if they contract, I have got these little suspensory ligaments dangling at the end. So when I'm relaxed, look, what do? I pull the ligaments. And when I pull the ligaments, my lens pulls. But now Abram comes rushing to me, right? I need to accommodate. So what do? My muscles contract, my ligaments bend, and when they bend, there's nothing pulling on my lens. And because there's nothing pulling on my lens becomes shorter and fatter. We say more convex. Okay, all right. So do you notice? Do I look, yeah, ridiculous probably. Okay, so remember, relaxed, accommodation, come quicker, ciliary muscles contract, my suspensory ligaments become less taut, they loose, so I don't have all this pulling on my lens, and what will happen? My lens can relax, and it goes shorter. Okay, and then Abram, when you're gone again, then I relax again. Okay, questions?
Right, question time and comments time. You'll excuse me, my network is...
Must I carry on with the question?
No, I do have questions for you.
Okay.
Right, comment from Diwali saying, hi guys, I'm from, I love you guys, I'm from Zimbabwe. Okay. Right. Hello guys.
You're keeping us in suspense, yeah.
I'm taking it.
Are you taking it one at a time? Okay. I'm going to find a question.
Please just find it in the meantime.
Okay. Right, I'm going to find. Have you found one? Okay, I'm going to do this. I do a question.
Please do. I've got a lot of questions.
You've got a lot of questions.
Okay, here's the first one.
Okay.
Shafi Solomons. Actually, yesterday it was her birthday, so happy belated birthday, Shafi Solomons. She says, what happens if the light that is refracted does not fall upon the yellow spot?
Okay. When the light does not fall on the yellow spot, I'm going to draw for you. it's going to fall off here. Okay. That's what we can't see. I don't know if any of you, usually people who wear glasses will be able to understand what I'm talking about. If the light doesn't fall where it should, now remember, here's all my cones and here's all my rods. Now I want you to try it. Tell us you must try it. Read your birthday card. And what you're going to see is, if you look straight in front of you, you're going to see the words very clearly, but the words on the side are very blurred. That's exactly what's going to happen. You're going not to be able to see something properly. If you're going to say it's blurry, you know, you see a teacher, I see in class, they're the ones who sit like this. Their eyes are all screwed up because they can't see properly. And that's exactly what happens. As soon as that doesn't fall on the fovea, your vision is not clear. And that is why you're going to need glasses. Okay?
Okay.
All right.
All right. Shileti says, which part of the eye is mostly sensitive?
The retina. The retina. The retina, when we talk about sensitivity, sensitivity means, all right, that there is, sensitivity means it's going to, a stimulus is going to cause a reaction. Now, I think what she might be asking a question there, if I'm not mistaken, if you have a look on this diagram I'm going to show you, there is a little structure over here which is not labeled, which is the conjunctiva. And that is also sensitive because it's got little nerve impulses. And that protects your eye from when you get something gets stuck in your eye, all right? That is going to protect your eye from getting damaged. So when she's talking about sensitivity, the retina, where all the nerves are, most sensitive, but she also might be talking about the conjunctiva. Why are you laughing at me?
No, I'm actually
you know
laughing.
I'm going to stab you.
I'm not laughing at you.
Listen
to this and listen to this. Listen to this. Mulukhadi says, I'm loving the show and I'm watching it with my little dog. Her name is Sarah. Please say hi to my doggy, Sarah.
Okay.
Hi, doggy.
Hi,
So
Sarah.
thank you for watching the show, Mulukhadi. All right. Tempo says, what's the difference between ciliary body and ciliary muscle?
You can use both of them. Okay, ciliary body, that's actually a very good question. Thank you. The ciliary body, generally we referred to this whole thing over here. So when I talk, it's almost like it's the whole part. So this is the suspensory ligaments, and this is the ciliary muscle. Together, they're going to make the ciliary body. But it's much nicer if you separate the one from the other. So one's a muscle, it does the work, and the ligaments is going to change suits. Yes.
All right. Okay, let's move right along. And I'm sorry to Sarah. Hey, I know Sarah is watching the doggy. Hi, Sarah. My director asked me to be more, because, my director loves dogs, So when Sarah is watching, he's touched. All right, let's move right along. Here's another question from Machabo. Macha was a regular here. He's always watching our shows. He says, is it the rod that makes us sing properly?
No, it's the cones.
Okay.
It's the cones. Guys, remember, the cones are your color. That is where, and that is on your fovea centralis. I think I drew it just now. The cones is the clearest. Look here, C. C, cones. C can stand, let's make an acronym. C stands for clearest vision. Make up rhymes so that you can remember. And color. All right.
Okay. Clear. Let's move right along.
You're so
Skill says,
funny.
watch.
Clear.
Skills T underscore skills 0007 says, thank you very much for helping us. I couldn't go to school today due to strike happening, but because of you guys, thank you. I'm catching up.
Awesome.
Thank you so much. That's what we need. Nigis, okay. Kilebogile says, hello, AB and our great teacher, enjoying the lesson. Thank you very much. Okay, I'm loving your show.
Awesome. We love it. We love the positive feedback. I do.
Indeed.
Everybody loves it when it's something positive, eh?
Okay, and when I don't see your questions, guys, please excuse me.
So I can
have
go
so many
on.
questions.
It's fine.
If you have a question, Cheryl, go over it. I'll tell you.
I'm going to. Okay. Guys, if we have a look at the questions, if you'll see the ones that I have already drawn on, if we have a look at this diagram again, you will notice it's a diagram of the eye. So first of all, what do we need to know? Our labels and our functions. So if we were to ask, supply labels for the parts numbered 1, 3, and 5. 1 would be my cornea, 3 is my pupil, and 5 is my suspensory ligaments. So if again you'll notice that very often there's my anatomy. Now if you have a look, supply the number and the name. Do not get that wrong. It's asked you for two things: the number and the name of the part that controls the amount of light. If you say pupil, I will be so disappointed. The pupil cannot control the light, okay? It is not a structure. So what controls the amount of light? They asked you for the number and name. The iris, which is number 2. So for your 2 marks, you would have to say number is 2, name, iris. Now, if you have a look at the next question.
All right, Cheryl.
Oh, we've got another
I
one.
have so many questions now.
Okay. Stride. Yes.
Kavarendo Mudau is asking a question of something that happened also on the show. Something that you did.
Oh no, what did I do?
He says when you're sleeping, well, you weren't sleeping.
Yes.
When you're sleeping and suddenly someone comes and switch on the light, the bright light, why do your eyes hurt when you immediately open them?
Sensitivity. Remember what we said? Right, remember, you've got nerve cells in the conjunctiva of your eyes as well. Bright light is harmful to us. So your body needs to be able to have a reflex action. So when bright light comes in, what's going to happen? The nerve cells are going to be triggered. So it's painful because it's sore. If it wasn't sore, would we do something about it? No. So say, for example, we did the reflex arc last week. If I put my hand on a hot stove and I couldn't feel that it was sore, I wouldn't do anything about it. Because when I open my eyes quickly and it's bright, you will also notice you start to blink. And when you start to blink, you close your eyes and you also just control the amount of light. Telling me, Mr. Ma, open his eyes very slowly in the morning.
Okay. Here's Penyo asking, I think I love Penyo's question because we always talk about driving.
Yes,
All right.
night blind.
So, yes. So, Penyo says, hi, how do we draw a line diagram to show how the lenses will help a person suffering from short-sightedness to see more clearly, especially when driving?
Okay. Right, especially when driving. Doesn't matter so much about the driving. If we have a look at the eye, okay, you will see, let's look at the eye. When we are short-sighted, I'm going to quickly go to, there we go. Right, when we are short-sighted, here's the picture. See what happens over here. Look at the curvature. I've even got it for you. When we are short-sighted, the reason is our eyeball is a different shape. So now because your eyeball is a different shape and you now have to say goodbye, tell him that's what he draws.
Okay.
Go to the notes, it's there.
Everything is on
Everything
the notes.
is there.
Thank you
Everything
so
is
much,
awesome
Cheryl.
there.
Thank you so much. And, you know, there's great feedback from Ramodikwe also saying, this is what I needed before my test tomorrow.
Awesome. Good luck.
I'm going to nail it. Thank you so much, Cheryl. And thank you guys for watching our show. Thank you to the Department of Basic Education for making sure that we have this show for you guys. We love you and peace.